Look at this question. Look at this question. Fill in the blanks. The volume of a cube of side 1 centimeter is equal to. These are the basic physics. Okay. Basic physics means area, volume, density. That kind of questions are there here. So here the first question is volume of a cube of side 1 centimeter is equal to. Look at this question. Volume of a cube of side is 1 centimeter is equal to dash meter cube. You know that what I mean by cube. Cube is, you know that, you studied in the lower classes. The cube is a box like this. All edges are equal. All edges are equal. The side is A. You studied in the lower classes that volume of a cube is A cube. If you don't remember, please memorize right now. Volume of a cube is A cube. The volume of a cube of side 1 centimeter. So A cube 1 centimeter cube. 1 centimeter cube. Okay, no problem. 1 centimeter cube. It's correct. But I want the answer in meter cube. I don't want answer as centimeter cube. I want the answer as meter cube. So what is 1 centimeter then? 1 centimeter equal to 1 by 100. This 100 to be taken to the other side, correct? So this 100 to be taken to the other side, or 1 by 100. Yes, 1 by 100 meter. 1 centimeter equal to, it's very simple, right? This 100 simply taken to the other side, that's all. 100 gone taken to the other side becomes 1 by 100 meter. So 1 centimeter equal to, let me write all the steps here. 100 is nothing but 10 square, understood? 1 by 100 is 100 is 10 square. I will write one result here. You have to memorize that. That is why I am explaining every step. 1 by 10 square is 10 raised to minus 2. Understood? 1 by 10 square is denoted by 10 raised to minus 2. 1 by 10 cube is denoted by 10 raised to minus 3 meter. Actually, you need to memorize this. In physics problem, we never use centimeter. In any physics problem, we will never use centimeter. We need meter. All the length should be in meter. It is a standard unit. So in questions they will give millimeter, centimeter, kilometer, something will be given. You must convert to meter. So this one you have to memorize. Never forget it. Okay, I explained the proof also. 1 centimeter is 10 raised to minus 2 meter. Must memorize. Along with this, there is one more result you need to memorize. 1 millimeter. Milli stands for 10 raised to minus 3. Okay. We will never use millimeter and centimeter in physics. We will use only meter. So these results you have to memorize. Never forget it. 1 centimeter. Centi means 10 raised to minus 2. Think like that. Milli means 10 raised to minus 3. 1 kilometer, that you know that. Kilo stands for 10 cube meter. 1000 meter. 1 kilometer is 1000 meter, right? 1 kilometer is what? It is 1000 meter. Kilo stands for 10 raised to 3. Kilo. So everything should be, all distance should be converted to meter. It's very, very important. So never forget it. So coming back to this question, 1 centimeter cube. What is this 1 centimeter? It is 10 raised to minus 2 meter. 10 raised to minus 2 meter all cube. Studied that raised to again raised to. If the raised to occur twice, raised to again raised to, we will multiply the powers. We will multiply the powers. 10 raised to minus 2 into 3. Correct. Minus 2 into 3 will be minus 6. Meter cube will be there, right? Meter cube. It is asked as a fill in the blanks question. So the answer is 10 raised to minus 6 meter cube. All of you please write. Now I am going to discuss the second one. You must know the basic mass. That's all. Basic mass is required. The surface area of the solid cylinder of radius 2 cm and height 10 cm is equal to dash millimeter square. Oh, it is challenging. The entire thing should be converted to millimeter. Okay. I will discuss that. Listen. Centimeter, millimeter. That is not difficult. Centimeter to millimeter. The second question is about a cylinder, right? You must know the basic mass. You studied in 10th, 9th and 10th standard. You studied about cylinder. Never forget the basic mass. The basic mass is required in physics. We have a cylinder. Cylinder look like this. The cylinder has radius r and height h. Cylinder has radius r and height h. The surface area. Look here. The surface area consists of two circles at the ends. These circles are the part of surface, right? These circles are the part of surface. Surface area means total surface area. You know that the area of the circle is pi r square. Pi r square plus pi r square will be 2 times pi r square. There is another surface which is a curved surface or lateral surface like this. Understood? This surface is there. It is said to be lateral or curved surface area. That curved surface area is 2 pi r h. Or you may memorize in this way, 2 pi r into r plus h. Never forget it. Let me put it in a box. You studied in the 9th standard. In 9th and 10th you use this formula. So never forget it. I obtained this formula from this formula. 2 pi r is common in both. That is why 2 pi r is taken out. So this formula is much convenient to use. So let me put it in a box. Never forget it. The surface area of a cylinder is what? 2 pi r into r plus h. Let me substitute the value. 2 pi is 22 by 7 or 3.14. Pi is 22 by 7 or 3.14. Studied it. Radius. What is radius? Radius is 2 centimeter. I need the answer in millimeter square. So let me directly convert each centimeter to meter. Right now I am going to convert centimeter to meter. You studied in the lower classes that centimeter to meter, right? 1 centimeter is actually 10 millimeter. 10 millimeter forms 1 centimeter. So 1 centimeter is how much? 10 millimeter. Studied it. Okay. So 2 centimeter will be 2 into 10 millimeter. Multiplying with the 10, you will get millimeter. So 2 centimeter is what? 20 millimeter. 20 millimeter. Let me write here r equal to 20 millimeter. Height is equal to 10 centimeter or 100 millimeter. H equal to 10 centimeter. 10 centimeter will be 10 into 10 millimeter. So 2 pi r, radius is 20 millimeter into r plus h is there, r plus h. R is 20 millimeter, h is 100 millimeter. If you use only millimeter, the surface area will be in millimeter square. If you use only millimeter, you will get the answer in millimeter square. So 2 into 3.14 into 20 into 120. And remember, I don't want to explain the multiplication and division steps. Multiplication and division I don't want to discuss. 2 into 3.14 into 20 into 120. 15072. 15072 millimeter square is the answer. C part I am going to discuss. See, a vehicle is moving with a speed of 18 km per hour. The covers dash meter in 1 second. You studied in the lower classes, I mean 9th standard classes. You studied that. I think you directly use it. I suggest you directly use it to convert kilometer hour to meter per second speed. Please memorize this. You studied in the lower classes. Please remember, kilometer per hour can be converted to meter per second by multiplying with 5 by 18. Please don't forget it. This is studied in the lower classes. Kilometer per hour can be converted to meter per second by multiplying with 5 by 18. So our question is 18 kilometer per hour is how much meter per second? Then we can answer this problem. Kilometer per hour to be converted to meter per second, so it should be multiplied with 5 by 18. Should be multiplied with 5 by 18. You will get meter per second. 18 cancels. 5 meter per second. So a body is moving with this much speed, meaning that that body cover 5 meter in 1 second. What is the meaning of the speed? In 1 second, the body will cover 5 meter. So in 1 second, 5 meter. 5 is the answer. In 1 second, the body cover a distance 5 meter. The third question is about density. You studied density in lower classes. In 11th standard, you have used it. The relative density of the lead is 11.3. Its density in gram per centimeter cube or kilogram per meter cube. This is the question. Aaron എന്താ വൈകിയത്? ആരോൺ ലേറ്റ് ആയത് എന്താ? ക്ലാസ് 8:30 എന്നാണ് ഞാൻ മെസ്സേജ് ചെയ്തിരിക്കുന്നത്. ആരോൺ 8:45 എന്നാണ് മെസ്സേജിൽ ചെയ്തത്. ആരോൺ ആക്ച്വലി 8:30 ആണ്. നമ്മൾ ടൈം ഫിക്സ് ചെയ്ത് വെച്ചിരിക്കുക, അത് മാറുന്നില്ല. ടൈം ഫിക്സ്ഡ് ആണ്. 8:30 ആണ് നമ്മൾ പറഞ്ഞു വെച്ചിരിക്കുന്നത്. ഞാനിന്ന് 8:45 ആക്കിയെന്ന് മാത്രം. ആരോൺ ശ്രദ്ധിച്ചിരിക്കുക. ഞാനൊന്നും ഒരുപാടൊന്നും എടുത്തിട്ടില്ല. ആകെ 3 ക്വസ്റ്റ്യൻ ഞാൻ ഡിസ്കസ് ചെയ്തിട്ടുള്ളൂ ഈ ടൈം കൊണ്ട്. ആരോൺ കേട്ടല്ലോ? ആരോൺ ABC, ഈ ABC എന്ന് പറഞ്ഞ 3 പ്രോബ്ലം മാത്രമേ ഞാൻ ഡിസ്കസ് ചെയ്തിട്ടുള്ളൂ. ഞാൻ റെക്കോർഡ് ക്ലാസ് അയച്ചുതരാം. പിന്നെ ആരോൻ്റെ കയ്യിലുള്ള ഒരു ടെക്സ്റ്റ് ബുക്ക് ഉണ്ടല്ലോ, അതിൽ നിന്നുള്ള കുറേ ക്വസ്റ്റ്യൻസ് എനിക്ക് ഹിയർ. The relative density of lead is 11.3. I am discussing the basic physics. Basics, okay? These you studied in the lower classes. Anybody? Some important results here. What do you mean by density then? Density of a body. First of all, listen. Density of a body is actually mass by volume. Mass by volume. You have studied that. For example, the mass by volume means 1 meter cube. Understood? 1 meter cube body has how much mass? How much kilogram? 1 meter cube. A unit volume of the body has how much kilogram? How much mass? Density of the ice means a unit volume of the ice has how much mass? Like that. That is density. Mass by volume. Density is denoted by the letter rho. Please memorize this. Density of water. This is very, very important. In questions, this will not be given. In question, no question, it will be, it will not be given in any question. Density of water, you have to memorize. It is 1000 or 10 cube kilogram per meter cube. It's very very important. I am writing here important. I am discussing problem based on the basic physics studied in the lower classes. Density of water is 1000 kilogram per meter cube, meaning that if you have a 1 meter cube water, it will have 1000 kilogram mass, like that. Density of water 1000 kilogram per meter cube. Relative density of a body. Relative density, let me write here. Relative density of the lead. Relative density of a body is equal to the actual density of the body. Actual density of the body divided by density of water. Please memorize this. You studied in the lower classes, so please memorize this. Relative density of a body equal to density of the body divided by density of water. Clear? That meaning that how much denser the body compared to water. Understood? We are comparing with the water. How much the denser the body compared with the water, like that. So we are comparing with the water. That is relative density. So relative density of the lead is 11.3. Given left hand side is what? Relative density. It is given as 11.3. Right side is density of the lead. Density of the lead we don't know. Density of the lead. Let me use the sentence. By density of water. Density of the water is 1000 kilogram per meter cube. 1000 or 10 cube kilogram per meter cube. Relative density does not have any unit. Remember that. Relative density does not have any unit. How much times denser than water? How much times denser than water? Does not have any unit. So 11.3 no unit at all. The relative density does not have any unit. Density of the body we don't know. Density of water is 1000 kilogram per meter cube. Let me write the unit. Cross multiplication. And memorize this one also. Density of the water is 1000 kilogram per meter cube is correct. Also please memorize this one also. 1 gram per centimeter cube. Both you can easily memorize. These are the basic results. These are the basic results you have to memorize. 1000 kilogram per meter cube or 1 gram per centimeter cube. You can convert to kilogram per meter cube to gram per centimeter cube, but you better memorize this. So density of lead, let me use some symbol like this. Density is denoted by rho. Density of lead. Do the cross multiplication. 11.3 into 10 raised to 3 kilogram per meter cube. But in fact, the denominator can be 1 gram per centimeter cube also. Denominator can be 1 gram per centimeter cube also. If you use 1 gram per centimeter cube and do the cross multiplication, the density of the lead will be 11.3 into 1 gram per centimeter cube. 11.3 into 1 gram per centimeter cube. Or 11.3 gram per centimeter cube. So density of the lead is 11.3 into 10 raised to 3 kilogram per meter cube or 11.3 gram per centimeter cube. You please read all these steps. If you please write down. So standard international units. This is the system of units which is commonly used in all countries. Okay, that is standard international units. I will show the standard international units. I don't want to write it because writing this will take time. Okay, writing everything will take time. Only the first three columns you have to understand. the definition is not required. This definition will not be asked in exam. Okay, no need. Only the first three columns, the symbols and meaning. I will discuss that. Let me select it. Just a minute. That's all. Okay, the standard international units are meter, kilogram. Meter for measuring length. The left hand side is for what purpose? The left hand side is the purpose actually. Okay, the standard international units are meter, kilogram, second, etc. The left hand side is this unit for which purpose, that is written in the left side. The standard international units are meter. Meter should be used everywhere, okay, in every countries. As per standard international system, the meter to be used everywhere in all countries. The meter, it is used for measuring length. The meter has the symbol M. And kilogram is another standard international unit. It is used for measuring mass. Symbol is kg. The third one is used to measure time. The symbol is S. You need to memorize it. Ampere. It is used to measure electric current. And symbol is A. Kelvin for measuring temperature. Symbol is K. Mole. There is another term, mole. You use in chemistry. Okay, in chemistry you use mole for measuring the number of atoms, number of molecules. We need a unit, that is mole. The mole is for measuring the amount of substance. Measure amount of atoms, amount of molecules, like that. Symbol MOL. Candela. You will learn more about candela in the higher classes. In our syllabus, it's not there. Candela is used for measuring luminous intensity. Brightness of a light. Candela. CD. Understood? Clear? Okay. And okay, you please write down. I will give you a small introduction about the significant figures. In this chapter, basically the dimensional analysis and significant figures. These two are the most important topics in this chapter. Dimensional analysis and significant figures. These are just theories, right? Have you completed? If you have written, please raise your hand. Please raise your hand if you have written. Deva, Aaron, all of you have finished. So the last topic in this chapter is significant figures. Significant figure, it cannot be completed today, but I can give you some introduction about significant figures. There will be an exam after the completion of this chapter. There will be an exam. So one topic is remaining significant figures. It is very difficult to understand. Most of the students simply memorize some standard results, simply memorize without any understanding. So but you must have a good understanding about significant figures. So what do you mean by significant figure? Nadasha, Aryan, please listen. Significant figure. Suppose I have an object. I measure its length. Suppose I got 2 meter. Somebody measure. I measured it. I have written as 2 meter. And some other person measured it. They have written as 200 meter. sorry, 200 centimeters, sorry. Another person measured it 200 centimeter. I forgot to write the unit. I measured the length, I got it 2 meter. Another person measured it, he got 200 centimeter. Another person measured it, he got 2000 millimeter. Let me write here, I will delete it. Another person measured it, he got 0.002 kilometer. Okay, the unit they can decide. You may be thinking that all of them are different. Are they different? Nadasha, Aaron, Aryan, are all these numbers different?
Yes, sir.
Different? No. If you read along with the unit, if you read it along with the unit, everything is same. Correct? 2 meter and 200 centimeter, both are same. Understood? 2 meter and 2000 millimeter, it's actually same. 2 meter and 0.002 kilometer, they are same. Somehow I dropped the unit. So the importance, okay, let me write the unit. Let the unit be there. Let the unit be there. 1 minute. Today I am just giving you the introduction only. Okay, by today's class it will not be over. It take time. Significant figure is very difficult to understand actually. So what I am saying is, there can be any number of zeros if we use the smaller units. Millimeter, micrometer, there are plenty of smaller units. Millimeter, micrometer, nanometer. If you use the micrometer, you may be getting 2 lakh micrometer. If you use a nanometer, you may be getting 2 crore nanometer. So the zeros, these zeros are not significant, right? These zeros will be keep on changing as we change the unit. Clear? As we change the unit, these zeros is not appear to be not significant, because zero may be keep on changing as we use the smaller units like millimeter, micrometer, like that. So the only thing is, only the 2 is significant. This 2 will be always there. Even if you change the unit, the digit 2 is said to be significant. That 2 will never be disappeared. If we use the smaller units, that 2 will never be disappeared. But 0 may change. Number of zeros may change. So I can say that only 2 is the significant digit. Other zeros are not significant because it will keep on changing if I use the smaller units. So the 2 will never change. You look at the all measurements, 2 is always there, but 0 is keep on changing. So only one significant digit is there in this measurement, which is 2. Is that correct? Understood? All of it clear? Hello? That all non-zero digits, like 5 or 2, like that, are significant. Significant means important digits, they will never disappear, like that. Significant figure or significant digit. Okay. In the case of 0, some types of 0 are not significant, but some zeros are important. I will explain which kind of zeros are not significant, which kind of zeros are significant. That part we will learn in the next class. Okay, so this part is clear. This part is, you have understood all non-zero digits are significant. That part is clear to you? Aryan, Aaron, Nadasha.
Yes, sir.
Okay, for the time being, memorize that part. The rest of the part I will discuss in the next class. Okay, I think that is better. So you please write down. If you have finished, you can leave the class. Okay. If you have any doubt, you please ask.
Thank you, sir. Bye, sir.
Okay.